Hi, everyone. Firstly, I would like to thank the ICAPS Awards Committee. It's a real honor to receive the ICAPS Best Dissertation Award, and I'm really grateful for the recognition. What I'd like to do in the next few minutes is to give you a very quick and brief run through of my dissertation titled On the Role of Large Language Models in Planning. So, LLMs need no introduction. These models have been like the first instance of this broadly knowledgeable system where they're able to generate like seemingly plausible completions for any domain that you throw at them, right? And when these models came about, there was like a significant interest in probing these models and attributing emerging capabilities to them. There were these papers that said LLMs are zero-shot reasoners, planners, etc., etc. And there is like from our perspective, there was little reason to believe that such like if you take the system one system two analogy, um, there was little reason to believe that such system one models could do system two style tasks, which require more deliberation, like planning and reasoning tasks. And what like but in order to sort of ground the conversation, there was a requirement to systematically evaluate whether LLMs can plan or help in planning at all. So in this dissertation, I basically asked this question, and there are three different parts to this dissertation. It starts off by evaluating like LLM planning capabilities in various modes. And note that I'm talking about vanilla LLMs. Um, and then along with evaluating the LLM's planning capabilities, I also come up with a framework in this dissertation where we can leverage LLMs, like LLM's idea generation capabilities to support planning. And finally, I investigate the recent class of LLMs that are post-trained on derivation traces for planning. So, in order to test the planning abilities of these models, I use the IPC domains, and I feel very happy that I don't have to explain IPC and PDDL and blocks world to this community. So what we did is we took these domains, we prompted these models in various ways, like natural language, PDDL, and more interestingly, we created mystery versions like of the blocks world domain by replacing the actions and predicate names with either random alphanumeric strings or words that cut down the common sense connections. And not surprisingly, we found that LLMs perform poorly, like even 3 to 5 blocks world problems. Um, they perform pretty poorly, and in the mystery version, it drops. Even though it's the same identical problem, the problems, the performance drops drastically, right? And I also created a benchmark where there was an LLM releasing every other week, so we wanted to uh, you know uh, 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 like give a benchmark to the community where they can test the LLMs as they're coming in, and uh, like I also tested the chain of thought prompting, which was claimed to unlock or enable LLMs in following and applying procedures. But we found that even if you give very very specific knowledge to the LLMs, they fail to sort of follow the procedure as you increase, like let's say the number of blocks. You give three block and 4 block problem examples, and if you test them till 20 blocks, they fail. You see like a very drastic decrease in performance. And we also tested a very similar thing in beyond planning, which is last letter concatenation. That was the domain that was used to show that COT works, and even there it sort of failed. And We also tested basically the planning abilities in self-verification loops, and we found that like this LLM plus LLM combo actually performs worse than the standard LLM, given that this sort of shows that LLM's verification capabilities are actually not that good. So it's not like all is bad. LLMs are still great at generating like candidate plans. So you could use them in conjunction with external verifiers, and basically we came up with this LLM modular framework where we could leverage LLMs. The idea generation capabilities of LLMs to support planning. Um, And we found that they obviously perform much better than the standard LLM prompting. And you could also use these LLMs as like in various other roles, like refining the problem specification, or using as uh, like using to extract domain models that can then be used as part of the external verifier, right? So um, uh, basically, that's the LLM modular framework. And more recently, I've been saying vanilla LLMs, and these, what I mean when I say vanilla LLMs is you provide a prompt and they just directly output the solution. But there was this new class of models where they were LLMs were post-trained on the derivation traces. So if you give a prompt to these models, they come up with these intermediate tokens, which people call thoughts or reasoning traces and so on and so forth, and then it comes up with a solution. So these are like the DeepSeek R1 and OpenAI O1 style kind of models. And we also in this dissertation we also investigated um uh, the planning capabilities of these models, and we found that they are significantly better than vanilla LLMs, but still they don't provide any guarantees in output on the outputs that they provide. So these can act as actually better candidate plan generators in the LLM modulo framework, and LRM modulo essentially shows pretty significant gains. Now, the last part of this dissertation, we look closer into the intermediate tokens uh, that these post-trained models generate, and there's a lot of anthropomorphization that's been done on these intermediate tokens, saying that these are reasoning behaviors and thoughts. So um, what we did is we trained transfer models from scratch on formally verifiable traces generated by A-star search. And uh, uh, Basically, what we did is we took a maze problem, and we trained models that are like two different sets of models. One set of model where you have the problem, trace, and solution of the same maze, and then we created a swap data set where we swapped the traces of the uh, uh, we basically swap the traces between the problems, keeping the problem and the solution the same. So ideally, if these intermediate tokens were actually reasoning traces or actually thoughts about the problem, then the SWOT model should actually perform much worse. But it turns out that the SWOT models perform just as well, or like if not better than the model trained on the correct traces, even though there is zero like trace validity for valid plans. So we also performed we also tested varying proportions of these swap traces, and we see that maybe as we keep as the percentage of swapping increases, it the accuracy decreases, and then again it shoots back up. So this sort of tells that it's not really like the intermediate tokens need not be meaningful or end user interpretable uh, for performance of these like reasoning models. So we also performed GRPO, and we found that the SWOT models continue to outperform, and post training actually reduces the trace validity of the correct models, even though it improves the solution accuracy. So overall, this is essentially what my dissertation talks about. It evaluates the LLM planning capabilities. We show that they perform poorly, and but we can use them to support planning in the LLM modular framework. And we also investigate the recent class of LLMs, which are called the LRMs, and talk about how they're significantly better, but still they do not provide any guarantees on the outputs. And we don't there is a lot of anthropomorphization that is done on the intermediate tokens that these models generate, and these models do not need require like an end user interpretable uh, uh, trace if performance is the objective. So uh, this dissertation has had quite an impact on the community. It also fetched me the 2024 IBM PhD fellowship. I also got the Dean's Dissertation Award and the currently the ICAPS Best Dissertation Award. And more importantly, I think it made Block's World great again. So I'm really, really happy for that. And I would like to thank my advisor, Professor Rao, my committee members, my lab mates, and all of my co-authors who helped me put a huge amount of this work out there. Um, so thank you so much, and please feel free to contact me for if you have any questions. And yeah, thank you.